Hello everyone. Today we are going to learn about configuration bits in PIC16F877A. These are very important because before a program starts running, the microcontroller needs some basic settings. These settings are called configuration bits. Let's check what are configuration bits in detail. Configuration bits are special settings stored inside the microcontroller. They define how the PIC will operate, such as clock speed, safety features, and memory protection. They are stored in non volatile memory. So, even if the power is removed, they remain intact. In simple words, configuration bits are like startup settings of the microcontroller. Why configuration bits matter? These configuration bits are very important because they control the overall behavior of the system. They decide which clock is used, whether safety features like watchdog timer are enabled, whether the system starts safely, whether memory is protected. If configuration bits are wrong, your program may not run properly. Next, we are going to check what is a configuration word. All the configuration bits are stored in a special location called the configuration word. In PIC16F877A, it is stored at the address 0x2007. This memory is accessed only during programming, not during normal execution. So, once we set it, it defines how the system behaves every time. Let's check the bits in configuration word in detail. The first bit is FOSC. FOSC stands for oscillator selection. It decides the clock source of the microcontroller. We have LP for low power crystal, XT for standard crystal, HS for high speed crystal, RC for resistor capacitor. Clock is like the heartbeat of the system. Without proper clock selection, the microcontroller will not work correctly. The next bit is WDTE. WDTE stands for watchdog timer. If it is on, the microcontroller will automatically reset if the program gets stuck. If it is off, no automatic reset happens. This is very useful in safety systems like robots or automation. Next bit is PWRTE. That stands for power up timer. If it is enabled, it gives a small delay when the system starts. This ensures that the power supply becomes stable before execution. Without this, the system may behave unpredictably during startup. Next one is boring or brown out reset. Boring stands for brown out reset. When it is enabled, the system resets if the voltage drops below a certain level. This protects the microcontroller from unstable voltage condition. It is very important in battery powered system. Next bit is LVP. LVP stands for low voltage programming. If it is enabled, programming can be done using a low voltage through RB3. If disabled, the RB3 pin can be used as normal digital pin. In most projects, we keep LVP off. Next is security and debug option. So, going to code protection. Code protection prevents others from copying your program. If enabled, program memory and EEPROM cannot be read externally. This is useful for protecting your project or product. Next bit is debug mode. Debug mode allows us to test and debug the program. If enabled, some pins like RB6 and RB7 are used for debugging. If disabled, they can be used as normal input-output pins. Now let's check how we can set the configuration bits. We can set configuration bits using MPLAB X IDE. First step is open configuration bit window. Next, select the required options. After selecting the required option, you have to click on generate code. Then a code will be generated and you have to copy and paste that code in your main program. This is the easiest way or method for setting the configuration bit. Now let's check an example for this. First, open MPLAB X IDE. Then click on New Project. Go to File and click on New Project. Click on Next and select the microcontroller name. So 16F877A. Select it and again click on Next. Now you have to select the compiler. So I'm selecting the first one. Click on Next. Now give a folder name, okay, project name. So I'm giving the project name as My LED, okay, and click on Finish. After this, you have to create a source file, okay. So I'm right clicking on it. Sorry. Click on New and click on main.c. Okay, and give a name for that file. So it will be LED. Okay, you can give any name. Then finish. So a new program location is open. Here we can set the configuration bits. Okay, below you can see configuration bits. Okay, click on configuration bits. First, in this pic, we are using FOC as HS. Okay, then we are turning off the configuration of WDTE. Then PWRT is off. Boron also, and we are setting it as off. Then LVP is off. Then, okay, LVP is off. Then CPD, WRT, CP, everything is off. After setting that, you have to click on generate source code to output. Okay, so the source code is generated. Then copy it. The entire thing you have to copy and paste it in your program before void main. Okay, this is how you have to generate the configuration bits. I hope you have understood what is configuration bits, right? Then how to set the configuration bits and needs of configuration bits. So thank you. We can see in the next class with a new video. Bye.